Welcome to lesson number 2, Graphing Inequalities. Please make sure you have a pencil and your paper ready to go. There are a few typos we need to take care of, so let's cross this second what out in that statement and the second what out in that statement. So let's look at what this says. What does x is greater than 12 mean? Well, when we use a variable, it's standing in for a number, in this case, numbers. It means all of the numbers that are larger are greater than 12. So let's write that. All of the numbers that are greater than 12. The next request is for us to make a list of 5 numbers that are greater than 12. So if I start with one that might be obvious, I might start with 13, or I could think about using fractions. I could also think about using decimals. And then I could increase it by many, 30, 100. So your list of 5 numbers might be much different than your neighbor's list of 5 numbers, and certainly my list of 5 numbers. So that's something we're going to talk about shortly. Let's also, while we're at it, get rid of that typo bill on my sheet. So let's go on to the next one. It says, what does x is less than 9 mean? Well, again, x is a placeholder for a number or many numbers. So we're looking at all of the numbers that are smaller are less than 9. So once again, we're asked to list 5 numbers that are less than 9. And so that could be 8.9, or we could even put 8.9 repeating. It could be 7. It could be 2 or 0. We could even go into our negative numbers, negative 20. So as long as those numbers are less than 9, that meets the requirement. And that brings us to this question. Can we list all of the numbers that are greater than 12 or less than 9? And we cannot, particularly in light of the fact that it includes not just the whole numbers or the integers, but includes the decimals. So this 9 repeating, we could use just an infinite amount of numbers. So we have to figure out a way to show all of the numbers that are greater or less than a given number. Since we cannot list all of the numbers, we use a number line to represent these numbers. Let's compare our answer to an equation to answers to inequalities on a line graph. So when we build line graphs, so we're going to do that in a minute, we would start with, I start my number lines with the number that is given. If I'm given an open number line, I start it there, then I put a couple numbers above and a couple numbers below as reference to this number line. Now, we don't have to start number lines always at 0, and some number lines don't increase in increments of 1 or a scale of 1. They might use a scale of 5, like 5, 10, 15, 20. But in this case, getting back to our point on this one, if I wanted to graph this, the only number that satisfies x equals 9 is 9 itself. And so we would show a point right on 9. That's the only number that would make this equation true. When we have an inequality, and I look at this statement, x is smaller than 9, or all the numbers that are smaller than 9, then I have to graph this differently. So I'm going to start the same number line. I'm just going to start with 9 in the middle and make sure I have a couple numbers below and a couple numbers above. Now I also want to make them consecutive. For instance, after 9 comes 10, 11 if we're counting by ones, and below 9 would be 8, 7 moving backward. So now let's graph this. I want you to notice that this says all the numbers that are less than 9. So this is very important. I have to show my reader, my graph has to somehow convey that 9 is not included. So for that reason, we put an open circle on the graph where 9 is. So we're kind of excluding 9 itself. So it's open, saying 9's not included, but we now want to graph, choose the side where all the numbers that are less than 9 exist. So we're going to graph the left side of this number line. I personally choose to darken my arrow. You don't have to. I just like that it makes it a little bit more obvious. Then great idea would be to check. Let's choose a number from this side. I'm just going to choose 7. I'm going to replace it where the x is. I'm going to substitute it where the x would be and ask myself, is 7 less than 9? And since that's a true statement, I know that my inequality, my solution in my graph is correct. So now let's go on to the third example. This reads x is greater than o or equal to 9. So x is greater than or equal to 9. We're going to start this graph exactly the same way. That this is kind of our key number that tells us we're going to place that 9 in the center. If it was 20, we'd put 20 in the center. Again, this is when we're building a number line. Many times, oftentimes, we're usually given a number line that's already built. But we certainly don't have to start at 0. So next, I need to convey that 9 is included in this because it's not only all the numbers that are greater than 9, it includes 9. It says equal to 9. So 9 could satisfy this inequality. 9 is greater than or equal to 9. So 9 is true. So we're going to put a closed point or a point on 9 saying that's part of the solution. And then I have to choose all of the numbers that are greater than 9. So I'm going to choose the right side of the graph. Again, I want to darken it, make sure it's very obvious that this is the side that's the graph side. And so once again, if I wanted to check and prove that this is correct, I could put in 10, which is on the the right hand side, and 10 is greater than. It's not equal, but it's greater than. And in this kind of inequality, it only has to satisfy either being greater than or equal to. So pause the video and complete these graphs if you need to. So let's review a very important point that we just talked about. When we have the less than symbol or the greater than symbol, we use an open circle, meaning that the number is not included. The number that we see is not included. So it does not, and it's not part of the solution. So the only way to convey that would be to put an open circle as we did in this example. Next, when we have less than or equal to or greater than equal to, we use a closed circle or a filled in circle, and that conveys that it does equal that number. So we used a closed or a filled in circle, and that's used to signify the answer does include the number as part of the solution set of numbers. Okay, so let's turn to the next page. All right, we're going to spend a little bit more time now graphing these lines. So here are the steps we need to complete in order to correctly graph an inequality. We build a number line with a given number in the middle. We show 2 numbers above and 2 numbers below. You can show more if you prefer, and this is important, in consecutive order. It means one right after the other. Be sure if the given number is negative, the number line is in the correct order. So if I remind you that on the negative side of the number line, to the left of 0, the numbers look like they're going backward. Number 2, decide whether the given number is part of the solution. If we're given the less than or equal to or the greater than equal to, it includes the number. And so in order to show that, we have to darken in or fill in the circle around the number. If we're given less than or greater than, they do not include the number. In order to show that this does not include the number, we leave the circle around the number open. And finally, decide which side of the given number includes numbers that make the inequality true. Substitute a number for the variable in inequality to test if it works. If it's true, darken the number line on that side. If it's not true, darken the opposite side. So let's go ahead and try this. Our key number here is 14, and so this reads x, all the numbers that are greater than or equal to 14. So I'm going to start first, as step number 1 says, building the number line. So I'm going to start with 14 in the middle, and now I'm going to put 2 numbers below, again in order, work backwards. So that's step number 1. Step number 2 says decide whether this number 14 is part of the solution or not. So let's go back to our inequality. It says all the numbers that are greater than or equal to, so yes, 14 is included. So we want to show that by enclosing or filling in a circle on 14. 14 is part of the solution. So now if I'm going to decide all the numbers that are greater than 14, I could test it before I graph it. So I think that these numbers are greater than 14. I'm going to choose one of them. I'm going to replace it where the x is and say, is 15 greater than or equal to 14? Well, it is greater than. As long as it fulfills one of those requests, it's true. So that means I am going to graph the right side of 14. So all of those numbers are greater than 14. So now I'd like you to try the next inequality, y is less than 8, and graphing it on your own. After you're finished, restart the video and check your answer. All right, so the graph should look like this, and what's very important is that there's an open circle on 8. 8 is not part of the solution. Let's try the next one together. We have a is greater than -6. All the numbers that are greater than -6. So we're going to use -6 as our given number in the middle of our graph, and now we have to really stop and think. As these numbers move up the number line, we would go to -5 and -4. It looks like they're getting smaller, but they're getting bigger, heading towards 0. We would have -7 here and -8. A very common error is to not build this part of the number line correctly. So now we have the number line. We want to make sure that we know are we placing an open circle? Are we placing a closed dot? And so let's look at the inequality again. It's all the numbers that are greater than -6. So I cannot include 6, so that means I need an open circle. And now here's the next tricky part. I need the numbers that are bigger than -6, are larger. And I might be fooled into thinking that these numbers are larger, but it's actually the numbers that are to the right, the numbers moving up towards 0. So we're going to go ahead and graph this right side, darken that in, and we want to indicate, by the way, I didn't explain the arrow, just indicates that this goes on forever and ever. I didn't explain that earlier. All right, very last one. You're going to notice I put a star, and this one's a little bit tricky. Some of you may have noticed a pattern as you look at the inequality sign and you look at the graph, the inequality sign in the graph, inequality sign in the graph. So you may be thinking you've run into a pattern, and you may have, except when we are confronted with problems like this. What is different about this type of inequality? Well, you may have noticed that the number is first and the variable is second. So let's go ahead and graph this and see if we can make any statements about patterns that we might see. So we're going to start with 20. That's the given number. I need a couple numbers above and a couple numbers below. So we built our graph. That's step number 1. Now I'm going to focus in on the inequality, and I see the less than or equal to symbol, so it includes the 20. 20 is part of the solution, so I'm going to place a closed or filled in point that denotes that 20 is part of the solution. And now here's where I have to be very careful. This reads 20 is less than all of these numbers. So basically 20 is smaller or equal to all of these numbers. So if 20 is smaller than all these numbers, I might want to pick a number and check this out. So if I'm going to read this, I'm going to say 20 is less than or equal to 18. Is that true? Is 20 less than 18? And that's not true. So that tells me that I have to graph the other side. So let's choose a number from the other side. 20 is less than or equal to 22. Is that true? And it is. So that's how I confirmed that this is the side of the graph I need to darken. And that's where all of my solutions are. So one of the patterns that students have in the past have noticed with the other inequalities, let me show you those again, is that when we have the variable on this side, on the the left side, that it turns out that the inequality symbol is kind of facing the same direction as the number lines, and that happened in these three examples. Now, suddenly when we had the number and then the inequality, then that pattern did not exist anymore. So thank you for listening and have a great day. See you next lesson.